In this video, we'll be looking into isomerism of alkane. Then we'll be starting from pentane down to what? Methane. A quick advice for you. If you really don't understand, or you don't really get, or you don't really know how to name organic compound according to AUPAC, I'm referring to nomenclature of organic compound. Maybe you're finding it difficult to name organic compound very well. So do well to write under the comment section that you don't really understand how to name organic compound. Then I will send you a YouTube link immediately that will guide you and assist you and give you better explanation on how to name organic compound. So I'm expecting your comments under the comment section. Now, before I proceed, the method I will be using to explain this isomerism to you or alkane to you is my own personal method. I mean the method I've been using to teach so many students, physical and both online, and the students are really getting it easily. So this method will enable you not to cram and you are not memorizing anything. It's just a pattern you're going to follow, the procedure you should follow. So do well to watch this video to the end. Share this video to your classmates, your friends, or anybody you know that is offering chemistry and really want to learn isomerism, particularly alkane. And don't forget to subscribe to our YouTube channel. Thank you. So let's start from pentane first. I'm starting from pentane down to methane, as I've said earlier. We know that C5H12 is the molecular formula for pentane. C5H12, that's the molecular formula for pentane. Whereas it has 12 carbon atoms with 12 hydrogen atoms. So let's start with pentane first. Pentane is C. It is 5 carbon. So it's filled with how many hydrogen? It has 12 hydrogen. Whereby 3 is here, then here is 1 here, another 1 here. We have 1 here, we have 1 here, we have 1 here, we have 1 here, then we have 3 here. This is pentane, right? Good. So this is a particular isomer of pentane. Like this is number 1. Let me remind you the definition of isomerism. Isomerism is the existence or occurrence of 2 or more organic compounds whereby they have the same molecular formula but different structural formula. Meaning that all the compounds we are going to be drawing now, all the isomers we are going to be drawing for pentane, they will have the same molecular formula, that is C5H12, but different structure. Different picture. Let me use that word. Sorry, but in chemistry we call it structure. So they will have different structures. Now, this is the first structure of pentane with C5H12 molecular formula, and the name is pentane. So let me write the name. So this is pentane, and I will name this one as the first isomer. So this is the first. That's the first isomer. So after you have drilled, or whenever you have drawn the first isomer, the main structure of that particular compound, which is pentane. After drawing it, then the next thing for you to do is to reduce the number of the carbon atom to 4. Reduce it by 1. You understand? So for instance, if you are doing for hexane, at first we are going to draw the 6 carbons for hexane first. So the next step you are going to take is to reduce the carbon atom to 5. I'm referring to hexane. But in this case, we are talking about pentane. So the first thing for you to do is to draw the 5 carbon atom first, fill it up with the hydrogen atom. Then the second step is to reduce the carbon atom to 4. So reducing the carbon atom to 4, this gives us C. This is 4. They'll be occupied with With hydrogen, isn't it? And we actually know that this guy is going to have 3 hydrogen. Whereby this guy is 2 hydrogen. This guy is how many? 2 hydrogen. This guy is how many? 2 hydrogen. Now, where is the remaining 1 carbon that remains? The remaining 1 carbon, you are going to turn it to CH3. Something like this is going to be here. This is CH3. Now let's count the number of hydrogen atoms we have here. 3 here plus 2. That's how many? I hope you are counting it. Plus this 2 plus this guy 2 that will be here, 1 here, 1 here, the 2 that will be here, and this 3. That makes it a total of what? Of 12 hydrogen, which means that we still have the same molecular formula, but the structure looks different. Now let's name this compound. Actually, know that this compound is what? Is still pentane, because if you look at the longest carbon atom known as the parent chain, that is 1, 2, 3, 4, 5. So this is still pentane, meaning that I cannot put the CH3 here. Now what would I do? Then I'll fix it here. If the 5th carbon atom is here as CH3, now what do you think this name is going to be? It is going to be 2-methyl butane, meaning 2-methyl butane. 2-methyl butane. So this is actually going to be the second isomer. So let me do this one as the second. Okay. Now the next thing for me to do is I should put this CH3 here, then let me put it here in this next carbon. If I put it in this next carbon, this is still going to give me 2-methyl butane, because I will start my counting from this carbon atom we have here, something like this. If I still have this carbon atom here, 1, 2, 3, 4, then I put the CH3, this particular CH3, if I put it here like this, so this name will still be 2-methyl butane. What do I do next? If I clean this guy here, let me rub it off. Then if I put the CH3, if I put it in this first carbon I have here, that's CH3, this definitely will still give me propane. Sorry, pentane rather. This will still give me pentane, because my longest carbon atom is going to be 5 if I count it. Starting from this 1, 2, 3, 4, 5. So this will still be 5 as pentane, meaning that I cannot, or I can no longer carry it anywhere again. So the isomer I can see when carrying the CH3 all around the O4 carbon is just 2-methyl butane. Now, for a case study, if you're working on hexane, still the same thing you will do. You ensure that you carry all the CH3 to all the carbon atom present. I mean, all the 5 carbon atoms that will be left. Ensure you carry. You put CH3 in everything, in all the 5. Then try to name it. So, and remember that don't repeat names. Don't let there be tautology. You understand? So I've done that. Then what do I do next? The next thing for me to do is to now reduce the carbon atom to 3. That's the next thing. So let me clean up this place. So if I reduce the carbon atom to 3, so how will it be? Something like this. That's 1, 2, 3. I reduce it to 3. Then let's check the hydrogen atom, whether it's still going to be 12. Remember, I have 3 hydrogen here, isn't it? 2 here, right? So this one can now accept just 1 hydrogen. So if it accepts 1 hydrogen, the remaining 2 places that remain, they will carry the carbon atom. And the 2 carbon atom is going to be as methyl, something like methyl, CH3 in 2 places. Now let's go. If I put my 2 carbon atom here as CH3 here, and also CH3 here, and also CH3 here. Okay, so let's try to name this. What is it going to give us? This is going to give me, longest carbon atom is 1, 2, 3, 4. This is going to give me 2-methyl butane. 2-methyl butane, meaning that I'm still repeating this guy. So let me clean it. It can't work here. Remember that you have to balance all this carbon atom with hydrogen. Take note, I'm not balancing it because of I don't want to make this video to be very long. So if I put the CH3 here and also here, CH3 here and also there, then what's going to be the name? This is going to give me 2,2-dimethyl propane. Let me write the name here. This will be 2,2-dimethyl dimethyl propane. So 2,2-dimethyl propane, and this is actually going to be the third isomer. So let me identify it as the third isomer. So after having the third isomer, then what would I do next? Look at the board. If I clean this guy, then I should put it here. Then what is that going to give me? Just imagine you putting CH3 here, you putting CH3 here. Then what will you get? What is that going to be? That is actually going to be 2-methyl butane as well. You can just try to work it out on your notes. Put CH3 here, put CH3 here. That's going to give you 2-methyl butane. Alright. Now let me just make a rough sketch here. You can see 1, 2, 3. Look at this part. 1, 2, 3 here. If I put remember that I've put CH3 here and here. I put it up and down here. I put it up and down here. Then what's the next thing for me to do? If I put CH3 here and here, remember here and here, what's that going to be? That will still give me 2-methyl butane. Alright, let me rub it off. So what about if I remember that I put the CH3 here and here, right? What about if I put CH3 here and also CH3 here? What's that going to be? That will still give me 2-methyl butane. Simply means that I can no longer put it anywhere again. So, in a nutshell, the isomers of pentane is 3. And what are the isomers of pentane? That is that is the normal pentane, 2-methyl butane, and 2,2-dimethyl propane. These are just structural isomers, or you call it structural isomerism. Recall that we have 2 types of isomerism. That is structural isomerism and stereo isomerism. Stereo isomerism, there are examples like they are classified as something like geometric isomerism, optical isomerism, the geometrical, optical, and so on. But this particular one is structural isomerism. So in a nutshell, pentane has 3 isomers, and mind you, when you get to carbon, like when you reduce the carbon to 3, that's the end. Don't bother to reduce the carbon atom to 2 and start carrying 3 carbons here and there. No, just stop the whole of everything at 3 carbons rather. Even if you are working for hexane, after they have reduced it from 6, hexane is 6 carbons, right? So if you reduce it from 6 to 5, carry the remaining 1 here and there, then reduce it from 5 to 4, carrying the 2 remaining carbons everywhere, then from 4 to 3, carrying the whole 3 carbons everywhere. Stop it like that. Once there is no anywhere to carry the whole 3 carbons, then you stop it. That's the end. Don't reduce the carbon atom to 2. Thank you. Now this is butane. You know that butane has 4 carbons, so something like this: 1, 2, 3, 4. How many hydrogen? It has 10 hydrogen, and the hydrogen is placed as CH3 here. We have 1 hydrogen here, another hydrogen here. We have 1 here and another 1 here, and we have CH3 here. Looking at this is C4H10. So this is the normal structure of butane. So let me name this as what? As butane. And this is the first isomer of butane. So let me give you first. Alright. So as I've said in the pentane, I said we are going to reduce this 4 carbon atom to 3. So if I reduce it to 3, that will be 1, 2, 3. I have 1 carbon left. So the 1 carbon left, let me put here as CH3. This still gives me butane, because if you look for the longest carbon atom, it still give you 4, which still means butane. Let me clean this. It's not going to be here. Then let me put it on the second carbon atom. Let me put it here and CH3. If I put it here, please always balance the hydrogens for all these carbons. 3 hydrogen will be here, remember. 1 hydrogen will be here, remember. Then 3 hydrogen will be here, don't forget. So this compound now is different. This compound is 2-methylpropane. 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 2-methylpropane, and this happens to be the second isomer. So this is the second isomer, 2-methylpropane. So what am I going to do next is that I will write, let me write out the carbon atom again. 1, 2, 3. I'll put the CH3 here. I'll put the CH3 on the second carbon. Then let me put the CH3 here. What about if I put the CH3 here? So what's going to be the name? The name is going to be butane as well. So, and I told you earlier that don't reduce the carbon atom to 2, just 3. Let the last stage be 3. So that's all. So in a nutshell, I have just 2 isomers for butane. And what are they? That is normal butane, then 2-methylpropane. Now let's move to the next example. Looking at example 3, that is C3H8, that is propane. Propane just have only 1 isomer. Remember what I've said earlier? I said, okay, let me write it out. This is C3H8. Looking at C3H8, draw the C3H8 and see how it's going to be. We are going to have the carbon atom 3 like this. That is 1, 2, 3. Then fill it up with hydrogen. That is H3 here, 1 hydrogen here, another hydrogen here, and then H3 here. So this is propane. This is what? Propane. And if this guy here is propane, like I told you earlier that don't reduce the number, don't reduce the carbon atom, the number of carbon atom to 2. Stop it at 3. And this is exactly on 3. So this propane only has 1 isomer. Now what do you think the isomer of ethane is going to be? It's still going to be 1. Ethane rather. Ethane, that's the example 4, C2H6, is still going to be 1. What do you think the isomer of methane going to be? It's also going to be 1 isomer. So that is it. Now let me give you a trial question for you to practice, and let me know your answer under the comment section. List the isomers of hexane and heptane. Take your time, work it out, then let me know the answer under the comment section. The isomers of hexane and heptane, that is, hexane is C6H14. Likewise, heptane is C7H16. Thank you so much for watching this video. Please do well to share this video to your classmates or any chemistry students who need to learn isomerism of alkane. In my next video, I'll be working on isomerism of alkane.